Today here we will see closed loop system. Okay, so closed loop system, there is a block diagram. In block diagram we have like this, this for addition and subtraction. We have this system operator, and this we give desired input and all that, right? We have plus sign here, and this goes like, we have now operator like the which is called driver, which will drive, it is a type like of a controller, you can say, type of controller to control of input and all the input signals, and which is passing through this, right? So we have now another block of accelerator, which will give a jerk on an accelerator. Required things will be completed here. We have automobile engine, automobile engine, which is a part of a plant, right? Which is a part of a system. Now after that we get if the desired output. Now in this closed loop system, we have closed loop system, there is control of input. We can control that, right? Therefore we pass, we therefore we pass signal as feedback, right? In the form of feedback we pass here, like this is form of a feedback. Here we have visual, yeah. Visual basically means like you can take it eye sensing of distance meter, right? Now it is go like this. You can add, subtract, whatever. So error is reduced here. So what is error? Like this, A, B, E. Error E is defined as A minus B. Here I'm just taking an example, right? So that you can understand, right? now system, we have linear and non-linear. A system is said to be linear if it follows the two principles, right? Two principles have to follow to be called linear. This is for linear. So first one is principle of superposition, right? Second is principle of homogeneity. These are two principles which any system has to follow to be linear, and right. Okay. So we are going to discuss to these properties. um, for a system, basically take a system. This is a system, right? This is a system. We have input, we have output. Basic definition of system, right? Now first superposition What is superposition? Basically, you tell me what is superposition. Superposition, when there are multiple effects, we take one by one and then that is added to a particular desired result. That is what is superposition is. So they take this x1, this x, y is in the form of output. So x1 is input 1, x2 is input 2, and y is output 1 and output 2, right? This is output, this is input. So superposition means addition of input is giving same addition of output. That means when I apply x1 giving out output 1, y1, and when x2 is applied, y2 is coming out, right? When I add this and this, we are getting the same result. This is same and this is also same, right? Now the second is homogeneity, right? Homogeneity is type, like homo means same property, like we can call it like a ceiling property, right? Ceiling property. And like x1 we are getting y1. If I apply alpha to input, I am getting alpha as well in the output. That is what is homogeneity property is, to satisfy linear system where alpha is arbitrary, arbitrary constant, right? Which can be any real value, any real value, any. Okay, alpha may even be 0. So you know what, 0 alpha, if alpha points to 0, then input is also 0, therefore output is also equals to 0. Why? Because alpha equals to 0. I told you this alpha x1 giving alpha y1. This is 0, this is 0, giving input equals to 0, equals to giving output 0, right? This is the case. So what I'm going to do, similarly we have like alpha is the case. For another system beta, we have beta giving out beta y2. Now superposition and homogeneity continuously. If I take superposition and homogeneity as I collaborate, I combine them, so what I get, alpha x1, sorry, this is x1 plus x2 giving y1 plus y2. This is superposition. Now I apply homogeneity property on this. How? See, alpha beta both, what both, superposition and homogeneity property are applied. Is it clear? Yes, sir. Okay, now I'm going to take some examples so that it is clear to you. Let's just take some example. First one is, you have to tell whether system is linear or not linear, right? So say non-linear. First one is y equals mx. Tell me. Pause the video and you tell me. Yeah, this is linear. Why? Now we have question why, right? Why? because I told you every input gives output. That means we can check by putting input equals to 0. If output coming to be equals to 0, then linear system. As you know, if I giving x is as what, x is 0, so what we are getting, y is 0, so therefore linear, right? I hope this is clear to you. Move to second example. Right. Let's take y equals mx plus c. Okay, right, mx plus c. now y equals mx plus c. If I'm giving x equals 0, what we are getting, y as c. Y is not equals to 0, therefore non-linear. I told you in the previous example, the previous concept as well. So moving on, we have d. Now taking difficult part, dy by dt plus t times y equals x, right? Now here take by, as we know, x1 is giving y1, right? Okay, then we have in this differential form, right? I need to convert this in differential form, so I need dy1 by dt. Okay, let's try this. I'm writing this in, in system 1 form, converting this system 1 form. So divided by dt plus dy1 equals x1, and as x2 is y2, so we have dy2 by dt plus t times y2 equals to x2. We have this system, we have this system. Adding, this is t1, this is t2, 1 and 2. On adding, what we have, x1 x2, right? This time something like this, y1 plus y2 giving a, sorry, x1 plus x2, something like this, right? Something like this. So what I do, it is something like superposition, so I'm trying to relate that. Plus t times y1 plus y2 x1 plus x2. Now see carefully, this is something y1 plus y2 giving your, just like this, x1 plus x2. What do you think? It's like superposition theorem. Satisfied, buddy. What are you doing? So it is satisfied. Hence it is satisfied. It is what? It is linear system. Hence prove this is what? This is a linear. I'm trying to lead from the previous one example. If I take example like this, dy by dt plus 5y equals 5x. I add a constant here like this is a constant I'm adding. So if I do try to from superposition, constant is going to create trouble for us. So therefore directly we can say not linear, non-linear. Which non-linear? This is non-linear because on x equals 0, not giving y equals 0. This should be for linear, but this is not equal. This is not. This is on putting x, we are not getting y equals to 0. So therefore non-linear. Now another one. Okay, just try to see. So it's cool. Okay. Fixed example is like this: y equals x square. Now do it yourself. Right? I'm just giving like this. If you're done, you can watch here. Solution here. Just adding. Right? What I'm adding? If I add x1, sorry, yeah, y1 is related to x1, y2 is related to x2. I'm just adding. Giving out what? x1 square plus x2 square plus x1 plus x2 whole square, right? So what is this going to be? Like something like non-linear. Okay, so definition of non-linear system, it's troubling a lot, right? So let's see the definition. Might come in exam, buddy. So system which does not obeys principal superposition and homogeneity. This is obvious, buddy. Right? Opposite of linear system. Right? This might, this should not be a trouble for you, right? It should not be trouble for you. So moving on. Let me tell you a thing. In this chapter, in this topic, further on, when we move, we have to deal with Laplace integrations and all that kind of thing. So let me tell you will see a variable like s. What does s stand for? S stands for something a complex variable. It is. So it is j omega. This might know this is d by dt. It's a lot of come down. This will come a lot of times, so you should remember this right now. Otherwise, blah blah blah. Okay, converse or difference in equation. Blah blah blah. Okay, serious now. Okay, now serious. We have classifications of system, and we have now properties of system, buddy. Woohoo! Properties. Oh man. Properties of system, right? Okay, serious. What you are doing? Sorry. Now, property of system, we have time variant. Obviously it is time invariant. Right? let me check. Yeah, this is time dependent, whatever it is. Time independent. Take this, match by this. Now if I take a system like S giving output y, x as input, dependent on time, see this, dependent on time, right? We zoom in. uh, Now if I have a property, apply a property by, if I take an interval of subtraction interval of minus t naught in time variant x t is giving output as yt now, and in x of t minus t naught this should be giving different output. This is, this is not same because this is time dependent. As the time passes the system changes. Time passes, system changes, right? Second comes on time invariant, right? As the name suggests, if I, system apply this should be same as x of t giving y of t. Because this is time invariant. Time passes, system remains same. I thought this whole page which I spent on my register is clear to you right now. Any questions, comment down below. Ah, hmm. Time when it has time shifting property. This is a very important key point. You might remember this key point. You should remember all the difference between time variant and all the going on, right? Now take some examples. First we are going to take y equals sine xt, right? This is the tell me this time variant or time invariant. Tell me, if you have looked this carefully, what I told you, that when the time changes the system also changes in time variant is a time shifting property. So if I put t as t minus t naught, then y, what we are getting y as y of t by t naught. Sorry, if I do this, step 1, if I do this, will I get this? No. Why? Definitely you can see, if I put this, I'm getting this as in the form of y. No, definitely not. So what, as the time is changing in x, we are not getting y in y. So definitely we say this is time invariant system. Okay guys, this is finished. I am finishing here. This is till till properties of system and system is linear, non-linear, time invariant, variant. I covered all these topics in this lecture. The next lecture is going to be on causal system, and on Laplace and transformations and integrators. All the things we are going to see in the next lecture. Uh, so stay tuned, buddy.